Software has a life. It's born, it's built, it's tested, then it's released. Throughout its life cycle, it's continuously improved upon. Improvements could be things such as bug fixes, cosmetic changes, features. Each of these improvements or bug fixes or cosmetic changes have a life cycle of their own. An improvement is also born, built, tested, and released. Really, the life cycle of software is cyclic until it reaches the end of its life. But today, we're talking about the life of software, not the death of software. It's a different story. So what do we call this life of software? We call it the software development lifecycle. But we have a fun little acronym for it, and we say SDLC, which actually, I think that's an initialism, not an acronym. I learned that the other day. By the end of this episode, you'll have a really good grasp on what an SDLC is and where it fits into the life of software. So where do we start? Well, I think one of the best ways to start things like this, a concept, is by looking at pictures, because I like to look at pictures and they can tell a lot more than I can in a short amount of time. SDLC diagram. Hey, look, I put that in before. So look at all these pictures. We've got a very iterative process: planning, defining, designing, building, deployment. Well, there's the good old waterfall. But let's go to a place where I know they explain it really well. We'll start off with the traditional waterfall approach. Let's say I want to build a calculator, right? In this, you would go through the requirements and you would collect what you're supposed to be doing, and you would design it, and then you would sit down and implement it, and it would go through testing, then deployment, and then finally all the way to maintenance. I mean, it's very easy to understand. Software goes through a very controlled workflow. What happens when you do something wrong and the implementation's wrong and something's found in testing? It's prone to problems. That's why other models have come about. So a take on waterfall is this iterative approach, which is you kind of go through the same waterfall process, except for testing, you go back to analysis. What was wrong? What happened in testing that caused something to not work right? So you bring it back. Finally, you go to implementation, but that's still a slow delivery model. You're still going through this process until you can finally get to implementation. So you'll see later on a different model that there are different ways to just think about delivering software. Here's the one that I see more often than not in everywhere I've worked. This one is what I think the most flexible. It's able to adapt to changes, because business changes their mind all the time, and they say one thing one day and they say something different the other day, and they might just be reacting to clients. Who knows? So in this model, you're collecting requirements, getting what you're supposed to be doing from whoever. You're designing it, which notice the arrow is going back. It's cyclic, so it can also be clockwise, counterclockwise, whatever. Architecture design might need more requirements, or then you go to development. You might go back and say, hey, architecture, you guys didn't do it right. Or test and feedback, back development. So the thing that it doesn't show here is getting out the door and moving. That's the agile process. You deliver, but we'll get to that. Birth. In the beginning, there was this thing. What was this thing? That is where we begin. When one thing begins, another thing ends. When one thing ends, another thing begins. So this thing, it needs to be defined. Well, this is typically where business people will come along and they'll define it. They'll argue about it. They'll decide what the client really wants, and then they'll deliver it. Now, during this phase where requirements gathering is going on, the birth of the actual software itself, scope should start being created. Scope is the boundaries which a thing is contained within. So the idea is scope, you don't want to go outside of it. That's called scope creep. But in the requirements phase, they're trying to define a scope. So the process that actually does the defining can vary from company to company. A company could just even have a single person who gets the requirements and designs it and does all that stuff. It could be this big process, this huge team, or it could just be a single person. I mean, what kind of organization are we looking at? You have to think about scale of the organization and scale of the actual process. So once something has been defined enough that they think this is something we should build or whatever. It usually goes into a system of some sort. It could be paper, it could be software that just says, okay, here's this thing, we want you to make it, and here are the requirements that we've gathered, go do it. But usually there is a system in place to help manage these ideas or these things. Once a thing is ready to be built, a team will typically pick it up and start figuring it out. As with all the steps, this will vary by the size of the company, but I'm going to go ahead and go from the enterprise level on this one so you can kind of see what the big approach would be as opposed to, a single person doing all these things. So the team now has this thing. It comes to them and they put it in this thing called a backlog. A product owner will typically take this thing from their backlog and look at it and refine it and smooth it out and make it look all nice and shiny. At which point it will then be presented to the rest of the team, and the team will then look at it and argue about it and say, do we have enough information? Is this scoped right? How would we build it? The team will get the thing, it'll be placed in their backlog, and at some point when it's ready to be worked on, the product owner, which is a member of the team, will take the item, make sure it's refined enough and it has enough scope, and continue to get more information about it if needed. Once this person who's looked at it, basically as a representative of business for the team, once they think it's in a good spot, they'll present it to either the team or a single person on the team to give a level of effort, which is an LOE, which is a really rough estimate that helps prioritize and figure out how long the team thinks it will take to be built. At this point, a release date is set. A release date could actually be set way in the beginning of the process, because there's a lot of times that business people will make a promise to a client that says, oh yeah, we can have this thing built in, a couple weeks, and then all of a sudden it's on the developer and the developer's like, nope. I'm going to take a step back real quick because I've been kind of all over the place here. So let me define this team and the roles so we can kind of get things situated. I'm talking about the Agile methodology. It's a process that I use a lot, and like I said, I see it a lot in the overview from earlier. This team is usually around 5 to 8 people, and typically you'll have one product owner and then a set of developers and testers, where developers outweigh the testers. Next up, this thing is shown to the entire team. How do they go about deciding how to build it? They could just say, here's this thing, here's how we're going to build it, and then just do it. They could also come along and say, okay, how should it be built? How will it fit into the entire system? How will it be tested? And how will it be released? Now, I have seen people go all the way down to the actual class diagrams to say, we'll create this little class and this little array over here. That's overkill, in my opinion, but I've seen people go to that level before. Now, with the thing finally planned and argued about and defined and scoped, we finally get to build it. During this building phase, a developer sets up their development environment for development, and they start typing away, or building the thing. As the code is being written, I would recommend that the developer looks to other people to take a look at their code to get another set of eyes on what they're doing. Now, this is more of a process around code reviews, but it's just the idea of having someone look at your code. So while the developers are writing their code, the testers should be preparing their test cases for the code that will be built. Defining here's what it should do and here's what we expect it to do, and kind of defining that rule set. Now, a good developer should also be testing their own code on their own machine to make sure that what they're building is doing what's supposed to do, but the real testing isn't done by the developer, it's actually done by a tester. So you don't want to be the person testing your own thing, because you're not gonna look at the weird side path that testers know how to take, because they're out there to break your code, okay? That's what they're there to do. They're just gonna smash our code, and then you're gonna be like, but it was so perfect. So when the thing is written, it's put in an environment to test. The tester will go through and actually start testing the system and making sure that the test cases that they wrote pass. If it does pass, then it's ready to go to be released. If not, then it can go back to the developer. Now, this can happen a lot. a developer could develop something, it could land on a tester's machine or whatever. They could test it, see it break, say, hey, this is what happened. It goes back to the developer. And this can go back and forth and back and forth. And that's what I call the churn. And it's not good. Usually there's a problem in the process when that happens. There was a miscommunication, maybe not enough requirements were gathered. Who knows? Avoid the churn. Some companies and some bigger companies will actually take testing to another phase, which it'll go from usually a test environment to basically a pre-production environment, which we sometimes call staging or we call pre-production. It's basically everything combined. And in this environment, testers will actually go through what's called a regression script. They'll say, does the system still operate as expected? Can I still log in? Can I still go to this page? Can I still buy this stuff? Whatever your system is, the regression is just to make sure that it still does what it's supposed to do. So it's done. It's done. We're ready for it to actually be released into the wild. Finally seeing our little boy grow up. Or girl, it could be a little girl. Finally seeing it grow up. And by growing up, it's actually just moving out into what we call production. Now, to get to this actual environment, good companies will have an approval place in process where the business person says, yes, this is good to go, or no, this is not good to go. You're unsure of the testing, or I don't like the way it came out, or it's not ready. But if it's approved, then it's slated to go for a release. So when our thing is finally out there in the world and it's running off on its own, it can still run into roadblocks and it can still hit things and it can still not turn left when it's supposed to. And hopefully these things are non-catastrophic. If they're non-catastrophic, usually the developers will quickly take a look at it, see if they can build something called a hotfix, which will then patch the release. Worst case scenario though, something got out the door, something made it all the way to production, and it's out there in the system, and it's, here I go, I'm running my race, right? Running my race out here in the wild, and then all of a sudden, come to find out that what we built didn't have legs. It breaks down the whole system. That's a catastrophic failure. If that's discovered, usually a rollback is put in place. So you take where the system was, and then you put it back to where it used to be. Sometimes that has to happen. Now, sometimes you can't go back, but good companies should always have a plan B all the way to Z, because mistakes happen. All right, so now we're getting into what's called SDLC management. Companies that are bigger have a lot of these little smaller SDLC cycles going on, or all these smaller things that are being built. So they have to have a way of managing it. Management can be done on paper, on a whiteboard, on a spreadsheet. It can also be done in specialized software. It's just software that's built to manage the building of software. In these systems, usually the thing is called an issue or a ticket or a story if you're using the agile methodology. But regardless, they're things. Now these systems they should do one thing, right? They should do that one thing really well. And in this case, they're managing the release of the actual software, the birth of it all the way to the release of it, and showing where the thing is, getting the approvals. Well, some companies out there have gone just off the rails and have actually created something that's insane, which I like to call awesome. And it's this entire life cycle and how software can be built at the beginning, going all the way through the process, collecting things. I'll use Atlassian, for example. They have the ability to take the stories or the issues, the things, move it through the system. They can put documentation in another system that they created called Confluence, and then the code can actually be built on a platform that is called Bitbucket, which is the source control, which can then be reviewed in Crucible, which is their code review platform, and then it can actually be deployed via Bamboo, or I actually prefer Jenkins. They have basically created an entire conglomeration of things that are there for the management of software release. It is a really insane process. You don't even have to get married to any of those systems. The idea is just that there is a way, and there has to be a way to actually manage the software that you're building, because companies will have more than one thing going on at one time. So the idea is you have these things and you have to track where they are. You can use a big piece of software or you can use a pencil and paper. To wrap up, no matter where you go in your career in software, you're going to encounter some sort of SDLC. You could be building websites for friends, but your friends are going to give you the ideas of what they need, and then you'll build it and they might say, I wanted that in the color red, not blue. That's an SDLC in a way. Now, everybody, even the big companies, will have different processes, and they'll use different tooling, and they'll use different methodologies. And that's okay, but you'll always see an SDLC. Software will go through a life. So I'll have a bunch more of those cool looking pictures that we Googled over there on my blog, and that'll be cool. You can go look at that, and I'll explain some SDLCs, and I'll try to define some of the stuff on copy and paste from other places. Oh, subscribe if you haven't. You can also question reality with me in the comments. That could be a lot of fun. We could, figure out how the universe was built. Well, until next time, adios!